welcome back. A very busy term in front of you. More so for Robin McCall. You can get there. Now, you're in about 13 months' time from now. Shh. My turn. 13 months' time. You'll be sitting your HSC exam, assuming you make it to the end. In your HSC exam, up to and including 30% of your prelim course, which will be get done in the next couple of weeks, can be assessed. The rest of the 70 or above % will be on what you do in the next 12 months. However, mathematics is a very building subject, so stuff you've learnt the previous year, you had to learn more foundation stuff the year before, or 2 years before, or whatever, pretty much right back to your start of your schooling days, okay? So you need to keep those things in mind, okay? That's what's coming up. Are there any questions anyone has to ask before we start the work today, now that you've got a chance to speak?
So it's 50% our exams, 50% HSC.
So your HSC mark at the end of the topic, the course, sorry, we've made up of 50% worth on your HSC examination, okay, that you'll be sitting in 13 months' time, and the other 50% we made up from your 4 assessments that you'll be doing for me over the next 12 months, okay? Now your assessments will be one a term, okay, so you'll have a end of term in-class task on what we get done up to and including them. And then towards the end of term 1 next year, it'll be a half-yearly exam. So everything we've done so far in your HSC course, probably we'll throw some prelim stuff in there as well. Then in term 3, you'll have, this is from memory, you'll have a 2-hour paper of everything you've done in the course so far. And then your trials, which will be a full-length HSC 3-hour examination on, and we will have the course finished well and truly by then. Okay, the way I got it set up, we're going to finish the whole course by the end of term 2 next year. Okay, so 3 terms for your work, and then there will be a term of revision to get you up to speed, ready for your HSC.
So much time.
It'll go very quick, I assure you now.
Okay. Will it be like the same as condensed as year 11?
Sorry?
Will it be like as condensed as year 11? Like, is that the idea?
In one sense, yes. In one sense, no. Okay. In terms of the, I guess you could probably call it how hectic it was in term 1, 2, and 3 so far this year. It does take a step back in terms of what you need to get done. However, there is more weighting on what you're covering in the next 3 terms, 4 terms technically, will be on your final examination. Okay. Now your assessments are 10, 20, 30 and 40% respectively for what you're about to do. Okay, and that will contribute to half your HSC mark for this subject. And that's of course assuming that you are going to make it. Some people need to do something about that before they've finished the course, okay? So they know who they are and you need to come and speak to me about it if you have anything you need to speak about your tasks that need to be done. Okay, any other questions? No? Okay, so quadratic function, which will finish your prelim course, and then in about week 3 we will start officially your HSC course. Alright, so I've given you the complete set of notes now from handouts. I've also printed off the end of introduction to calculus, just so it forms the booklet. Okay, so on page 68. Okay, so now looking at chapter 10, the quadratic function. So, also in the next couple of weeks, you will need to go to the library and get a textbook. Okay, so it'll be exactly the same sort of book as your prelim, but it's a purpley colour, not a greeny colour. Okay, so you need to get that. There should be enough books for everyone. There was only 3 students completed it last term for the HSC course. And of course, that's within the next couple of weeks, sorry, because you're still using your prelim books for this one. And Robin and Mikhail, you need to make sure you get yours soon because you'll be starting your exercises for the HSC course for your extension subject. Okay? Have you got something to write on? Would you like something to write on? Okay. Alright. 10.1. So, graph. Okay, so we should all know that a parabola is the graph of a quadratic. Okay, so remember the quadratic has the highest power of x, or any other letter that you use, of 2. Okay, we've done a lot of work on factorising quadratics, expanding quadratics, using the quadratic formula, completing the square, functions and quadratics. And basic arithmetic with quadratics as well. Right, so we need to graph using the intercepts. Okay, so the graph of the quadratic function is in the form y equals ax squared plus bx plus c, which will form a parabola. Right, so to get the parabola, we first find the x-intercept by either factorising, then solving, or we can use what's called the quadratic formula. Have you seen the quadratic formula before?
Y equals, no, not y.
Alright, quadratic formula.
Didn't let me start.
Alright, so x equals negative b plus or minus square root b squared, take away 4ac, all over 2a.
It's 10 kilos of pasta.
Now, remembering that there are 2 possible solutions for most quadratic equations. Not all, most of them. Okay, so the plus or minus in front of the third will give you the different solution. Okay, and then a's, b's and c, so the equation was y equals ax squared plus bx plus c. You obtain those numbers out of your quadratic equation or expression, and you substitute in for the relative variables into the formula. Now, you have done work before in factorising and solving equations of the quadratic nature. If you substitute the variables into the quadratic formula, you will get the same answers as if you would go ahead and factorise and solve your quadratic formula. Okay, so that will be one handy one to memorise. Okay, so if it's not straightforward to factorise and solve, okay, this is your next option. Okay, and then the next one after that will probably be completing the square. Okay, so to find the x-intercepts, we substitute into that formula there. Okay, so to find the y-intercept, we put x equals 0. Okay, so remember, finding the intercepts of each of your axes, you put the opposite letter equal to 0, and then solve for that, for the intercepts. Alright, so examples. So we're going to sketch the following parabolas showing all points where they meet the axes. Alright, first one, y equals x squared. Now say with confidence that everyone here should be able to just do all that. Okay. Now, you don't need to do table values. You don't need to plot point accurately. Okay. You just need to do the basic curve shape of a parabola with your axes and any intercepts that we have, and that will be sufficient enough in most cases, to answer your question. Right. So, your graphs need to be a third of a page, okay? Still people doing less than that in their exams. Alright, you need to do your graphs on your assessments, okay, minimum third of a page. Okay, so I would suggest you get in good habits now by doing that in your work. I know it takes up room, but it gives you the right habit ready for your exams and assessments. Okay, don't forget we need to label your axes, X and Y, with arrowheads on it. Use a ruler, don't freehand. Okay, and with a bit of practice, okay, so a parabola there is an even function, so it means what happens on the left hand side of the y-axis repeats in reverse on the right hand side. Right, now because it's the origin, we don't need to show that intercept value. We're showing clearly that it crosses at the origin. And that is of course our standard parabola form. Okay, so we get some practice and doing nice smooth curves in there once you get a bit of practice. And then they will hopefully start to come second nature in terms of the motion you need to do. Right, B. Okay, x squared, take away 2. So what comment can we make about the layout of this parabola?
It's going to be to the right way, or to
No, down 2. Okay, you've got to remember these differences. You need to, both you boys need to stop. Okay, you need to remember the differences. Okay, so if you have y is some function of x, and then you add a constant, your graph will be shifted upwards or downward the value of that constant. Alright, if you have y equals f of x plus c, that's the one that's shifted in the opposite direction of that constant. Okay, so if that was the case, this one would need to be y equals x take away 2, all squared. Okay, so that bit has to be incorporated within the function. Okay, and of course we've got some constant times f of x. It just changes the steepness, but the general layout is the same. Okay, so that's what we went through last year. If you need a refresher on that, you need to go back to the video to watch that again, or go back through your notes to get that. Alright. So, the value of the constant you're adding here is negative 2. Alright, so that means your graph, your parabola, will be shifted down 2 units. Okay, you don't actually need to do the axes a different colour. Okay, you don't need to waste your not waste, but use up your time in your assessments doing that. Okay, I'm just making it a bit more illustrated for our purposes. Alright, so we're shifted down 2 units. Okay, so let's redraw that parabola from above. Make it as symmetrical as you can. Okay, I'm not expecting them perfect, neither your markers, however, we aim to get as close as we can. Maybe not like that, Kyle.
The bottom point is over here.
It's like a circle incorporated with the parabola. We'll get there. Okay, so remembering how to find our intercept. We sub the opposite letter equal to 0. Okay, so y is going to be 0 squared take away 2, which is negative 2. Okay, which is that point on the y-axis. You need to label all your intercepts unless told otherwise to do so. Okay, we did this back in the functions and graphs topic, how to graph things. Well, one of the key things you need to do is find where they cross the axes and then your x-intercept. Y is 0. Okay, set the opposite letter equal to 0. So 0 is equal to x squared take away 2, and then we want to solve that equation for x. Okay, so x squared is 2 by moving the negative over to the other side, and then we of course take the square root of both sides. And when we do, that's when we have the 2 possible solutions. Okay, so you need to show that when you're taking the square root. Okay, and graphically that makes sense because there are 2 intercepts on the x-axis. Okay, so x, that means x is square root of 2 and x is also negative square root of 2. That's what that plus minus sign means. Alright, so we label it. Okay, so always, where possible, label your intercepts. Any questions so far? Alright, so y equals x squared plus 3x. Right, so this will be a parabola because the highest power of x is 2. Okay, so that's, you will know straight away that that's a parabola for the graph. And now we need to sketch that. Okay. So remembering, one of the most useful things in sketching is finding your x and y intercepts. Okay. When you find those and put them in the correct location, that will be often enough to get the value of the solution. Alright, so y-intercept, set the opposite letter equal to 0 because any coordinate on the y-axis has the x value of that coordinate 0. So y is 0 squared plus 3 lots of 0, which is of course 0. Okay, x-intercept, y 0. Because any point on the x-axis has the y value of that coordinate as 0. That's why we are able to do this. So, 0 is x squared plus 3x. What's my next line looking like?
Is this going to be a weird looking problem?
No? get there. Alright, so take out the highest common factor, which is x, out of both of those. Factorise x plus 3 is equal to 0. Going way back to chapter 2 exercises, or chapter 3 actually.
I remember doing this in year with Mr. Harper. It was like blowing my mind. I just couldn't get it.
Yep, and that's why he was showing you.
I don't get this one. How was it? Why?
What?
How was it 0 and 3, but the y-intercepts on
The
0?
turning point doesn't have to be at the one intercept. You're thinking of it like that, as a probably that. But the turning point doesn't have to be on the x equals 0. You're thinking of it as like that. It's like that. It's just the turning point. Wait.
Okay, yeah.
Yeah.
Alright, so after factorising and solving using your chapter 3 skills that we've covered quite a long time ago now, feels like a while ago. So let's do a quick rough sketch just to make sure we're happy with the layout before we do our good copy. So y-intercept is 0, so we are crossing the origin. X-intercept is also 0, so that's the common origin point, and x is -3, somewhere over there. Okay, so we only had 2 intercepts, or we had 2 intercepts. Alright, and we need to draw the parabola that best fits through those 2 intercept points. And it's that one there. Sorry?
Would that be multiple points? So, like, you're like the one that best fits through, couldn't that be at multiple angles coming either way?
I don't quite understand what you're asking.
Well, you said you draw the parabola that best fits both points.
Yep.
But couldn't the...
Oh, you mean it can go up and down?
No. Couldn't the bottom bit, couldn't that be at multiple points? Like, anywhere?
Yes, but in general, just sketching this graph, that's where it is, okay? That's what I'm saying. We don't need to have that particular value here matching up with what's here, as long as we've got the general shape of that parabola there, okay? And the next thing we're about to talk about is that concept there, but we'll get to that. Okay, so once you're happy with your rough sketch, we can do a proper one. So you can rub out your answer from part A and reuse that axis and draw your next one. Okay, now my advice to you, don't put the points in, okay? Draw the parabola first, okay? Don't put the point because that means you have to put your parabola through this point here, okay? My suggestion to you is to draw your parabola going through, not the best one, going through those and then go back and label your intercepts, okay? So negative. Okay, because if I put a dot there on the axis, that means I'll have to get my parabola through that point. I would say I have a decent chance of doing that, but until we're really good at these, I suggest you do it that way. Okay, so the comment Amanda was making, the value is this, yes, we can work it out of course, and that's what we're coming up to. However, just for the purposes of illustrating intercepts and the general layout of your parabola, that will be fine. Okay? Right, D. X squared, take away 5x, take away 6. Okay, so to graph your parabolas, find your intercepts, and then put your parabola through the best motion through those intercept points, depending when you have 0, 1, 2, or 3 intercepts. Alright, so y-intercept, set the opposite letter equal to 0. Okay, or you just read the constant number in that polynomial there, or that quadratic specifically. Bless you. Okay, so somewhere down here we've got the point where it crosses the y-axis. Now for these styles of parabolas, you only have one value of your y where it crosses, because we can't have the parabola going this orientation and crossing at more than one place. Alright. Alright, x-intercept, set the opposite letter equal to 0. Alright, let's see who remembers what to do next. Factorise, how?
Plus into that one, times into that one.
It's minus
Negative
6 plus
6
1.
plus 1.
Good, okay. So, to factorise a quadratic, okay, which is common with factors, two numbers multiplied to give the number at the end, negative 6, and the same two numbers you add and you get negative 5. Okay, that was way back in chapter 3 as well. So the two numbers are negative 6 and 1. So negative 6 times 1 is negative 6. Negative 6 plus 1 is negative 5. Okay, and that was covered way back in chapter 3. So, x take away 6, x plus 1 equals 0. Okay, so a reminder, when you have these things factorised, when you're multiplying between terms, each part of the term that's multiplying can equal 0. Okay, because once you've got one thing that's equal to 0, and you multiply it by whatever else you want to multiply it by, you will always have 0. Okay? So, x take away 6 is 0, x is 6, x plus 1 is 0, x is negative 1. Alright, before we go ahead and sketch this, I want now to have a go with the quadratic formula. Okay, so the purpose of the quadratic formula is we're going to get these two answers out at the very end. Okay, so x squared take away 5x take away 6. Right, your formula, negative b plus or minus b squared take away 4ac all over 2a. Okay, and remembering which letter goes which part of your...
Well, that's wrong.
Okay, let's have a go at the quadratic formula. So what is the value of b?
Negative 5.
Negative 5, okay. You've got to be making sure you're including your sign. So you've got a negative 5 plus or minus negative 5 all squared. Okay, that part needs to be brackets. That means that value will always be positive. Minus 4. What's the value of a? 1. Okay, the coefficient of x squared is 1. And what's the value of c? Negative, including the signs, okay? All over 2 times 1. So to a we've already established as 1. Okay? So if you've forgotten how to factorise, or you would prefer to use your quadratic formula, okay, either way you're getting these answers so that you can answer the question. Alright, so negative becomes a positive. Negative 5 all squared, which is 25. So you've got minus 4 times 1, which is minus 4, and then you've got minus 4 times, so the result of minus 4 times negative 6. Okay, so that becomes a plus. Multiplying to negative, you'll get a positive. Okay, so what I'm also illustrating today is you don't need to go to your calculator. Okay, this is pretty straightforward, this instant. You don't need to go to your calculator to do every little thing. What's the square root of 49? Okay, so x is equal to 5 plus 7 all over 2 for the plus, and then for the negative, 5 take away 7 on 2. That's the outcome once you've got this form here. Okay, so you rewrite the expression both times with the opposite sign, with the alternating sign. So one has a plus, one has a minus. So 5 plus 7, which is 12. 12 divided by 2 is 6. Okay, and 5 take away 7 is negative 2. Negative 2 divided by 2 is negative 1. Okay, so you can use your quadratic formula if you prefer. However, you do need to know your factorising skills. Okay, so rough sketch, probably a good idea. In some, don't have to. Okay, but just to get you started, y is negative 6, x is 6 in proportion, and negative 1. Okay, so you're thinking about how your parabola is going to go through those 3 points when you've got one point that's significantly out further. Okay, so if that's the case, the turning point is going to occur somewhere around here. So in other words, it's going to keep going down because these two are closer, but because these two are further away, you've got more distance to cover in the horizontal direction, means this is going to still go down and then turn around and come back up this way. So something like that. Okay, once you're happy with your sketch, do your good copy. Alright, again, I wouldn't label these until the very end. And once you've done some to practice, okay, you'll get the general hang of drawing a nice smooth curve. Any question? Okay, so I've got 10 minutes, so I'll finish up that section so you can do exercise 10.1. Okay, so the next thing we're going to talk about is the axis of symmetry. Remember that time you asked me where it turns around? How do we know what value that is when we were drawing quadratics for your polynomial section? Yes? Hopefully it'll come to you soon. Okay, axis of symmetry. Okay, so the axis of symmetry is the imaginary line that gives the parabola symmetry. So the parabola with vertex on the y-axis is an example of an even function because we've got the symmetry of the axis. So, in other words, is that vertical line that gives it symmetry on either side. That's what's called the axis of symmetry. Okay? So using that, we can obtain further information about the equation of the axis of symmetry. So, the equation axis of symmetry for the quadratic equation, y equals ax squared plus bx plus c, x is negative b on 2a. Okay? Now, what can you tell me about the intercept of the axis of symmetry compared to the intercept of the parabola? Halfway. Okay, so we've got symmetry. So in other words, the symmetry will be halfway between -1 and 6. Okay, so what's halfway between -1 and 6? Okay, so 1 plus 6 is a total length of 7. Half of 7 is 3.5. So from either end, you need to go the other direction 3.5. So in other words, 6 take away 3.5 will get you to 2.5. -1 plus 3.5 will get you to 2.5 as well. Alright? Now, if you substitute that into the formula here, that will give you the x value of that axis of symmetry, or in other words, the equation of the axis of symmetry, because it crosses the x-axis. Okay? So that's really just the midpoint of your x-intercepts for your parabola. So, depending on the values of A, parabola is either concave upwards or concave downwards. We've talked about this before, haven't we? Okay, so coefficient of A is greater than 0. We have a concave up parabola. It opens upwards, opens in the upward direction. If A was negative, I think we talked about in the locus in the parabola maybe. A is negative, it opens in a downward facing direction, so we call that concave down. So after you've done your intercepts, you then need to establish whether the coefficient of x squared is positive or negative for you to determine the correct location of the orientation of your parabola. Okay? So, if we have A is greater than 0, we have a concave up parabola like this, and we have here what's called a minimum value. Okay, so it's the lowest value of y that exists for your graph of your parabola. Now, when A is greater than 0, less than 0, we have our concave down parabola, depending on the other values of B and C as well. And then we have what's called a maximum value. Okay? So concave up parabolas have a minimum value, concave down parabolas have a maximum value. That's really saying the maximum or minimum values of y that exist for your graph. Okay, so examples. Find the equation of the axis of symmetry and the minimum or maximum value. E. Y equals x squared plus 3x, take away 10. So you ask to find the equation of the axis of symmetry and then hence find the minimum or maximum value depending on the value of A. So what is A less than 0 or greater than 0? Greater. It's a concave down parabola, so we have a minimum or maximum value? Minimum, because we have an infinite value for your maximum value. Okay? So, x is negative b on 2a. So b, including the sign, is negative 3 over 2 times 1. So it'd be 3 over 2. Or, of course, you find your intercept of your x-axis and then get that midpoint. That will also give you the same answer. Okay? So, that is the equation of the axis of symmetry. It crosses the x-axis at 1/2, 3 over 2. Okay, so we have a minimum. So how am I going to determine that?
Solve them simultaneously.
Don't need to.
So you just change
Okay.
the constant.
You just put in x.
Yes, but what is the value of that constant?
The negative of the A. Isn't that
It's not going to do with calculus.
Nope.
I'm just putting
Making it way too hard.
3 over 2 squared equals. You just put it into that equation.
Exactly. Yeah. This is the x value.
Simultaneously.
This is the x value. Well, it's not a simultaneous thing. It's a substitution. Okay? So, you've got an x value. Once you substitute into formula, you'll get the corresponding y value. Yeah? So, yes, I can understand.
I don't know why it's
Oh my goodness.
I think you were confusing everyone else when you said that.
It's on the equation.
Alright. So, you simply substitute the value of the axis of symmetry into your original equation. Okay, so put that into there. Y equals 3 over 2 squared, take away 3 lots of 3 over 2, take away 10. And that will give you that y value. And that's what we were saying before, when you get that specific point. Okay? You'll get that specific point when you do this one. Alright, 9 over 4, take away 9 over 2, take away 10. Anyone game after we went through this?
Use your calculator. Use your calculator.
9 on 4, take away 18 on 4, take away 40. 4. Give me everything a denominator of 4, multiplying the numerator where necessary.
Negative 49 over 4.
Negative 49 over 4, which should be negative 12.25.
How do you do maths with decimals? I can't.
Okay, so in context, x value is 3 over 2 and the y value is negative 49 over 4, which is negative 12.25. So somewhere way down here, that is that turning point of your parabola. Okay, you can use that information to sketch it. Last one before the bell goes. Last one before you go. F.
Are we just finding the minimum point?
Sorry.
Are we just going to find the minimum value?
Because this is all it's asking to do, find that minimum value, so you don't need to sketch it and then find it by using midpoint, and just use your formula. Alright, y equals negative x squared, take away 4x. Alright, the value of a is negative or positive? Negative, so we've got a concave down parabola, and we have a maximum turning point. Okay, so x is minus b on 2a. So b is negative 4, so negative of a negative 4 all over 2 times negative 1. So 4 over negative 2, negative 2. So that's the x value of the coordinate for the maximum turning point. So maximum value y equals, now watch this, negative 2 or squared. Okay, if I wanted to square that negative, 1 it wouldn't need to be there, and 2 if it was it needs to be brackets. Take away 4, lots of negative 2, take away 12, work that out and they'll give you the y value, the biggest value for y that will exist for that. Exercise 10.1.